All right, we're going to talk about the Unix touch command. Most of us know it as the command used to create a new file. It creates a nice new empty file for you, and that's generally what you see it used for. But why is it called touch? Well, if we look here, we can see that touch is a utility that sets the modification and access times of files, and then if any file does not exist, it's created with default permissions. So we generally use it for that if condition there. And that is the primary case that you'll see it used for. But of course, it does a lot of other things. And you can see that it was around for AT&T Unix, and this particular version was for BSD in 1995. So one thing to note is that when we say Unix commands, we're talking about Unix commands, Unix-like. Mac OS, which I'm on here, is a Unix-like system, but it is based on BSD. It has nothing to do with Linux. So you oftentimes hear these commands called Linux commands. And yes, they are commands that work on Linux, but these commands predate Linux. And so these commands work on BSD-based systems and Linux-based systems, and there are a few other NIX-based systems. So Mac is based on BSD from way back and obviously has changed a lot over time, but there is nothing Linux about Mac. But these commands, because they predate either these separate BSD distros and these separate Linux distros, they work on both. And so that's why they work here. But then oftentimes on Windows, you need to get an equivalent machine, because Windows has nothing to do with Unix, except for now there is a Unix subsystem. Let's take a look at how this works here. All right, so if we look in here at these files, you'll see these are all C files. And if we want a prettier look here, we can look at exa and see that we have C files. So let's go ahead and make these C files into executables just to get an idea of what we're working with here. Okay, so now if I look in here, we'll see that we have all of the binaries built. They're good to go. So if I run make again, it says, hey, there's nothing to be done here. Well, all right, that's fine. Now I'll go ahead and take a look at poll.c here, and I'll just poke around. Okay, nothing going on there. That's fine. I have a buffer open in Neovim here. No big deal. And let me try to make again. Nope, nothing to be done. Okay, great. All right, so let's touch poll.c. We haven't changed anything. We've just touched it. But now let's see what happens when I go to make. Aha. So this time, make and GCC decided that, hey, you touched it, that changed metadata, that's good enough for me, I need to rebuild it. So we haven't changed anything as far as contents go, but that's good enough for GCC to say, hey, we're going to remake this thing. Okay, cool. That gets impacted there. And you can see, if we look at poll.c, and that is at 10:54 on February 1st. That's when it was last touched. Now, hopefully enough time has gone by to where we can update that. So let's go and say, okay, it's 10:54 now, touch poll.c, and we'll LSA, and 10:55. Okay, and not to be confused with the binary above it, which was last built at 10:54. And of course, now we know if I do make, it's going to want to remake it because we just touched it. And so now you'll see that we have 10:55 for both the poll executable and poll.c. So we know that here it matters as far as GCC and make are concerned. It's going to build those up. Now, let's take a look at what happens if I am in a Git repo and I touch a file. So we'll touch index. Well, that doesn't trigger Git because the content of the file doesn't change. The hash is not changed, so Git does not care. So that doesn't matter to it. All right, now let's go over here. And what we're going to do is we're going to start server here. And just a little server program called microdev. If I go here and I say touch this file, look at that above. You'll see that the server restarted. Okay, and so again, the server restarted. Now I haven't changed any contents of the files, I'm just touching it. So that's different. Here, it considers that to be a file change, just like it did over with GCC, because it's a metadata change. So as far as it's concerned, it's time to restart. That's a file change. It's been touched. Whereas Git does not care about touching the metadata. It only cares about the contents of the file. So it's good to understand how touch works and what you can use it for. Now you know why it's called touch. Read the man pages and read about the history of touch. And next time we will go over another Unix command and see what we can do with it. All right, thank you very much for watching. Appreciate it. Like, subscribe. Talk to you later.